Ever stood on the beach and wondered why there are always endless waves coming? Or wondered why some waves are perfect for surfing while others look like they are not even trying to make a decent barrel? Hey, I'm Frank, a civil engineer who happens to love sketching, and today we're diving into ocean waves, and I'm going to talk about why waves exist, how they're formed, and what makes some of them so cool. Welcome to the world of offshore engineering. Before we get into what causes waves, let's get clear on what a wave actually is. An ocean wave is the movement of energy through water that causes the surface to rise and fall. So, pretty much, a wave is energy flowing across the ocean. When a wave passes, the water, and anything floating on it, mostly just goes up and down. It's not the water that travels, it's the energy moving through it. But where do ocean waves come from? Most waves we see at the beach are wind-made, but made very far away from the beach. We will talk about this later. Wind transfers energy into the ocean's surface through friction, turning tiny ripples into full-on waves. And the size of these waves in open water depends on three things: wind speed, wind duration, and fetch, aka the distance the wind blows over open water. Not all waves are made the same. They're sorted by frequency, which means how often they pass. Long waves have a short frequency, like tide waves, basically moon-powered waves due to the gravity of the moon and how close it gets to the Earth. Medium frequency waves are usually bigger, such as tsunamis, which are formed by earthquakes, and they can cross entire oceans without losing much energy. And finally, the most common are wind waves, which have the biggest frequencies. Waves don't just stay near where they're born, they can travel huge distances. For example, a swell can originate in the South Pacific Ocean and travel to the North Pacific Ocean. Therefore, the waves we see at the beach could have originated in other oceans and from more than one swell. Now things get fun. When a wave enters shallow water, it slows down, but the back of the wave is still in deeper water and moving faster. That causes the wave to bunch up. It gets taller and narrower. And since waves can't get infinitely tall and skinny, physics says nope, they tip forward and break, dissipating energy. When a wave breaks, it can do two things. It can spill, or it can plunge, making a nice barrel. If the beach slope is gentle, the wave loses energy gradually. It spills. That makes a soft, foamy mess. Pretty much the meh of waves. But if the beach is steep, the wave loses energy fast, and it plunges. That creates those beautiful surf-worthy barrels. So yeah, nice waves are just controlled crashes and with good angles. Thanks for tuning in to Sketchy Engineering. And if you learned anything new, go ahead and like and subscribe. I'll be dropping more videos like this.